This is our last lecture, and essentially we need to summarize everything and get prepared for our final exam, which, by the way, is already posted, right? So this is our homepage, and I'm already giving you access to the final exam, which is going to have exactly the same interface, and you know how you need to practice a few times to make sure that you prepared adequately, because you know it randomly pulls questions from the pool, and the more you practice, the more familiar you become with all of the questions. So hopefully it's quite doable, and I hope that everybody has fun doing this. And in the meanwhile, we need to still cover a few topics today. Now, one of the things I wanted to mention is that last week video recording went well for only half of it, and the second half was essentially, I think that Visual Studio window malfunctioned, and it's basically made itself somehow invisible, so that didn't work. So I actually had to scramble a little bit, and what I did was I pulled similar 4 lectures from the class that I did earlier, maybe a year or 2 ago, and did an example with shapes. So today I will probably continue doing this, but just be aware of it. So I actually had to replace something I posted on YouTube only partially, and then added a few lectures from another class. So that we can you still get the same coverage. So to summarize what's going on and where we stand right now, I would like to perhaps start with just talking about a few conceptual things that we're already aware of. So basically, we say that in object-oriented concepts that we're trying to cover in CIS 123 is basically we started with variables, right? Variables. We talked about how they look in memory, right? That was early on. Then we started talking about functions, and we can say C functions primarily. That's where our textbook did a lot of talk about C functions and organization of their calls, right? And we also... Right, so we said that C functions are also located in memory, right? Then we discussed that later on it may be beneficial to organize both variables and functions into something we call objects, right? And so objects will include both functions and variables, right? And in that case, we say that objects can contain in their own memory member variables, and member functions, right? But then we said that before this can happen, and we can have basically an object in memory that contains the member variables and also has or provides member functions, what needs to happen that before an object can be created somehow, we need to say that we have a class, right? So we have a class, for example, a circle. If circle wants to provide information about the circle, we need to declare it conceptually and describe what that circle will be when the object is created. And at design time, the syntax is very simple. We'd like to draw boxes, right? So on the top of the box, the name of the class goes. For example, circle is a class name, then it follows by the section where the data members are located. For example, it's we can specify where the center is, right? And we can say the size of its radius, right? And we can provide these two components so that basically the member variables for the circle will have the center and the radius. 2 pieces will be allocated inside this box when we create an object. And then, of course, we can later on add operations to our classes, and those will be typically constructors, right? Constructors, we mentioned constructors, which allow us to efficiently initialize our objects with some initial data, and then functions such as, for instance, get area, right? Get area. So that is the basic approach to get organized and get everything started with using object-oriented features. Essentially start using classes and then ability to instantiate objects of these classes. But then last week and the week before, we started talking about the situation with pets. For example, like cat and dog and other types of animals or pets that can be organized into some kind of application. We discovered that if you have, so we can have base classes and we can have derived classes. An example would be like a pet would be a base class, and cat would be a derived class. And when we talk about these types of relationship, we said that we use these arrows with hollow triangular heads to specify relationship between the pet and a cat, and the two classes can be programmed separately, but at runtime what happens is that when, for instance, an instance of a cat class is created in memory, and I will draw this as another box right here on the sideline, basically the combination involves that a pet class will be placed inside the cat, and that will allow us to basically work with the combination of a pet and a cat, and we say that cat inherits everything from a pet, and that includes both data members and member functions that the base class can have. So I would like to quickly reinforce some of these ideas just by quickly going and making an example, a project example, and this time to avoid any kind of technical glitches, I will switch back again to use my code blocks. To create a new project and essentially run a series of these demonstrations today.